Alright, so for this tutorial, we're going to look at using Kangaroo, not Kangaroo 2, but the original Kangaroo, to create a cloth drape simulation over a solid object. The first two things that you're going to need in your grasshopper definition is your surface or your cloth and your solid object, which is your BREP. Both of these are going to be made in Rhino, so you can just draw them in there, and then you internalize both of their datas into the definition. The solid object, not very much is going to happen to that over the course of this definition, so we're going to kick it off first with modifying the surface. So using that leader, you want to place and attach the mesh BREP component. The mesh BREP, of course, is going to take that data from the surface and it's going to turn it into what the boundary representation outputs. But the other input is the settings, and you put down the mesh settings, and then in that you can define basically your grid density. So how many squares you want this mesh to be defined by. Um, so using this slider, we're able to, make it as little as 14, or we can do it up. I have this up to 500, but around 300 is fine. The higher you go, that's that much more math that the definition has to do, so it can get pretty intense on the computer. So define the density of your mesh and then input that into your mesh BREP, and then you want to take that, and then one of the leaders outputting from that is your deconstruct mesh. And so after you deconstruct your mesh, then we will start tackling what is called the first goal. Kangaroo thinks in goals. The goals are found here in forces. This definition uses three separate goals. It uses the unitary force, which you can think of as gravity. It uses, I believe, collide surface. That's what's going to allow you to simulate the cloth being draped over the solid. And then it uses springs from line. Almost every definition using Kangaroo has springs from line as a goal. So that's just kind of a standard. So the unitary force, like I said, is gravity. Um, our gravity, we want it to act as it does on Earth. So once we let go of the cloth, we want it to drop. So using our deconstruct mesh, we define the vertices of it, and that allows this goal to figure out what the gravity is being enacted upon, and then we need to give it the information for the force. So we want it to fall once we let go. So we give it the input of a z factor. So you can see down here, our z-axis is up and down, and we can see by these leaders that it's going to fall once it's released. The number slider, the factor, tells it which way it's going to fall. So if this was a positive number, these leaders would be the other way, and this unitary force would allow the cloth to float. But since we want it to drop, we give it a negative factor. We'll hide this so we don't have to look at all of these leaders. For the second goal is springs from line. So this gives the mesh some structure to it, and it allows it to act with the physics that we would expect to see. So it has some structure, it has some friction. So basically, all you need to do to accomplish this goal is you need to take an output from the mesh BREP. You need to plug that in to your mesh edges, and both of these outputs, naked edges and interior edges, get combined and put into a curve component, and then that output gets put into both the connection and the rest length. You can watch some other people's YouTube videos that describe what this rest length does, but for this definition, it's pretty simple and straightforward for this, so that's all you have to do. So that accomplishes goal number 2. Goal number 3 is collide surface, which is what we want this definition to finish with. We want the cloth to be draped over the solid. So like I said, the cube in the beginning, you don't really need to do anything with it except for this one step, which is you take that and you plug it in to the solid of this component, and that's it. The points you get from the mesh deconstruction, which is the same component that you get the points for the unitary force. And then all three of these goals get plugged in to a merge component. The merge component is very important because it takes all of that data and it basically flattens it, and it gives you a good point to organize your definition, because after this is where we get into the Kangaroo heavy components. Um, so taking this merge component, you take that leader and you plug it into your Kangaroo physics. This Kangaroo physics component is what you start off every Kangaroo definition with. But with that merge, you want to put it into force objects and flatten it. Your force objects basically means, it says it right there, all force inputs. So all of your goals are your force inputs. So that's where that gets plugged in. The next important one is your geometry. The geometry of this definition of this Kangaroo simulation is not the box, it is the mesh. It is the surface that gets draped over top of it. So that's your output from your mesh brep. That gets plugged all the way in to your Kangaroo component. And then your last super important one is your simulation reset. This is the basically, like I said here, it's your start and stop button. That's what the Boolean toggle does. And then the timer is basically your refresh rate, and that determines how smooth the simulation is going to be. I will show that once we do the simulation. For this one, you need to put in Kangaroo settings. I haven't seen very many tutorial videos where they have to mess around with this, but this one seemed to need it. And the only thing you need to specify on this is the floor and what state it's in. So this surface that we drew in Rhino is drawn on the C-plane of the world. And so if this floor component was set to true, um, Grasshopper and Kangaroo would see this C-plane as basically, like, think of it as like a dinner table, like the top of your dinner table. So if that was set to true and we would try the simulation, this surface would just sit here. It wouldn't fall through. By setting this to false, it basically turns that invisible, and it's able to fall right through on top of the component. So you can set this all up right, but if your floor is set to true, then it's never going to move, and it's going to be a pain to figure out why. So this only takes 4 inputs: force objects, settings, in this case, geometry, and simulation reset. The simulation reset only has one button. This timer is not plugged into the simulation reset, as you can see. It's just plugged into the component, so you just have to drag and drop this leader to this entire box. It doesn't need to be plugged in. There's two components that you can use to control simulation reset. There's Boolean toggle and there's a button. I use a Boolean toggle because that allows you to start your simulation and that allows you to stop your simulation. A button only allows you to reset it, so your computer continuously has to compute what is happening with it, and it can be pretty intensive on your computer. So I just want to cut down on that because I don't really have the hardware to run it. Particles out and geometry out. The particles out, that was just me double checking to make sure that my grid density is still the same as when I specified that at the beginning here. So I'm going to hide all of these so we don't have to look at that anymore. And I'm also going to hide my initial surface geometry. This surface is not going to be the one that is simulated once you use Kangaroo. That's just your input. The surface that's going to be animated is this one, your geometry out. So anything before that, any component before that, is just data you're putting in. It's not going to be shown as data coming out. So we have to make sure that we turn the geometry out on and the initial surface off. And that's basically your whole definition. This is just kind of some housekeeping stuff and allows you to look at your definition, or allows you to look at the simulation and makes it a little bit prettier. You don't have to do this. You can just cut it off at this component and be done with it. With this, it allows me to see my grids, and it changes my grids to red and my surface to white, so I can, it'll look a little bit nicer when I do it. So with all that set up, with the floor turned off and with the Boolean toggle set to true, in the true state, it is set at its reset point. And once we turn it off, or once we turn it to false, it won't be, it's basically reading that as it's no longer in its reset state, therefore the whole simulation happens. So you just have to double click true, and it falls down, and it wraps around the cube. Why it doesn't wrap perfectly around it, I'm not entirely sure. I'm still trying to figure that out. Um, but I think for right now, I mean, that's a pretty solid simulation. Um, this timer, I will show you what I mean about its refresh rate. So 20 milliseconds is the fastest interval that it has. If it was set to 500 milliseconds, it's a lot choppier. This doesn't give you a really smooth simulation, but it allows you to kind of see step by step what's happening. So if you're doing quick tweaks, set it to the 20 intervals because it'll just do the whole simulation. But if you want to kind of break it down and see what's happening, then set it to a longer duration. Um, but most of the time, 20 milliseconds is fine. I will show you the difference between a button and a Boolean toggle. So right now, it's set to true, false, and then we can just turn it off and it stops computing. It no longer has to think about what all these grids are doing. If instead it was a button, you can see immediately as we connect this leader, it starts. Um, and then the only thing this button does is it resets it, and if you click and hold, it holds it in that state, but as soon as you release, it lets it go again. So, you know, you click it, and you want it to stop, and it can't. So your computer has to continuously figure out what's going on, and that can get pretty intensive. So that's why I use the Boolean toggle, so I can just have it stop and not have to think about what it's doing. So that's basically this whole definition. Once again, it's using Kangaroo, not Kangaroo 2. On Food for Rhino, it says that Kangaroo only works for Rhino 4 and 5. I'm using Rhino 6 and it works perfectly fine. And that seems to be a case for a lot of the plugins actually. So that about wraps it up. Thanks for watching.